So we're taking a look at this again. Whenever we are going to have matrices and multiply them together, make sure that you identify it rows by columns. Rows by columns. First matrix, second matrix, always write them down next to each other like this. Then you can check the columns. So remember, this can multiply together because these are both 2. This cannot. Because when we took a look at this last week, when we were doing it, we had written it down, wrote down the rows and columns in the wrong way. So always make sure it's rows by columns. Rows by columns. Okay? So, then we also had talked about that once we had identified which ones are going to be in which order, the outside numbers identify what our finished matrix is going to look like. So, when we had taken a look at this, just to go back over it again, can matrix A and matrix B be multiplied together? And the answer we said was yes, because this number and that number are the same. So we would get a yes out of that. When I take a look at these two, this would have to be a no, because it would be a 1 and a 2. Even if I were to go and change the order, I still would not be able to multiply them together, because that would end up giving me a 2 by 1 multiplied by a 3 by 1, even those ones. So again, keep that in mind. Now, the last thing I think I had you guys doing was writing this out. So you should have that all written out in your notes right now. And we were taking a look at working through this. So I'm going to go back over it again. One of the things that I had said is the first one that we multiply, first offhand, is can I multiply these things together? Rows by columns. How many rows? 3 rows. How many columns? 2. Rows by columns. How many rows here? 2. How many columns? 2. So, can I multiply this together? The answer is yes. I got a 2 here, and I've got a 2 there. So we can multiply these together. Now, we are going to write this out so that we can multiply them. If I go back here and I take a look at this is always by the rows. I know. This is by the columns. So what I want to do is I want to write it out rows by columns. I want to write that all out again. So, here I go. Rows by columns. So first row, first column. 2 times 1 plus negative 3 times 4. Now I had said that there was an easy way of writing this thing out so that we kind of get things going quicker. First row, second column. So what I generally do is I write down 2 times plus negative 3 times. That takes care of my rows. What's the column going to be? 2 and negative 5. If I can get this process down, it makes life a lot easier for setting it up. Kind of eliminates the question of it. Second row, 3 and 1. So I go 3 times 1, 3 there, plus 1 times here. Again, since I'm going to use the same row on the next column, I'm still going to get 3 times whatever plus 1 times whatever. The question is, what's the column? Well, first column is 1 and 4, so guess what? 1 and 4. Second column is 2 and negative 5, so I put it back in the same order again. 2 and negative 5. Okay. By going and using this idea for the setup, it makes life so much easier. So 4 and 5. And again, we end up over here with 4 and 5. So what goes in? row. 1, 4, 1, 4. So guess what goes here? 1 and 4. 2, negative 5, 2, negative 5. 2 and negative 5. So again, it's that idea of once you see what the pattern is, keep using that pattern over and over and over again. So now, if we want to go and do the math, this gives me 2. That gives me negative 12. So if I add these together, I end up with negative 10. Here, 3, 4, add them up, 7. 4, 20, 24. Over here, 4, 15, add them up, 19. Here, 6, negative 5, 1. 8, negative 25, negative 17. Once you get done doing this, always put them back in with the brackets. If you just list the numbers like this, it is not a matrix. You have to put the square brackets around it in order to identify it as a matrix. That is what must be done. Questions about that? Anything you've seen up here, any of the process? And it's going to take you time to do these things. Okay. Question. Can I multiply those together? Rows by columns. How many rows here? 1. How many columns? 3. So this is a 1 by 3. How many rows over here? How many columns? 1. So can I multiply this together? Yes, indeed I can. And this is an easy one to deal with, isn't it? Now, mind you, this is a 1 here, that's a 1 here, so I know it's going to come out as a 1 by 1 matrix. Well, a 1 by 1 matrix is just a plain old number. So that means it's going to be negative 3. Negative 3 times whatever, plus 0 times whatever, plus 4 times whatever. Here, my whatevers, 2, negative 5, and 1. I am going to tell you this over and over and over again for the next year. Do not do calculations in the middle. Write everything out, then calculate. 9 times out of 10, the errors are made simply because you're getting ahead of yourself. So, for here, negative 6, 0, 4. The answer is negative 2. Do I have to put the matrix brackets around it? Absolutely. Otherwise, this is not a matrix. That's it. It looks flat out ugly. I understand. It's a lot of writing. But the math behind it is not that complicated. Just take your time with it and go. So, you guys are well aware that if you multiply numbers together, you get the same thing, right? Because 3 times 2 is, what's 2 times 3? 6. 3 times 2 and 2 times 3 is the same thing. Yeah. 5 times 10 and 10 times 5, same thing. Order of multiplication does not matter. However, does the order of multiplication matter here? So, we're going to have to do the multiplication and see if AB is actually equal to BA. So I'm going to write this one out. This is a 2 by 2, that's a 2 by 2. Can we multiply them out either way? Works great. So, that means I'm going to have negative 1 times something plus 0 plus 0 negative -1 plus 0 times. Then I get another -1 plus 0 times. Down here I end up with 3 times plus -2 times, 3 times plus -2 times. Rows by columns. This row, 0, -2, 3, -2. Do that right? Rows by columns, I wrote the wrong ones in. My bad. Rows, columns, so that's got to be 5 and 0. 5 and 0, correct? There, now we're right. -3 and 1, so -3 and 1. -3 and 1. So now we get to do the math. Well, that's 0, that's -5. So I end up with -5. Here I get 15. That's 0, so that's going to be 15. Here I get 3. That's 0 there, so that's gone. So that's just as 3. Here I get -9 minus 2, so I get -11. So I got that matrix done. Those are called. So now, I want to do it the other way around. So I'm going to take B first and multiply it by A. If you need to, write it out so that you've got them in the same order. Okay. Otherwise, you can note that, okay, it's going to be rows by columns. So over here, this is going to be 5 times plus -3 times. And over here, it's going to be, again, 5 times plus -3 times. Down here, this row, those columns. So this is going to be 0 plus 1. 0 plus 1. Remember, we're always going and writing out what our rows are first. Row 1, numbers are there. Row 2, numbers are there. Column 1, -1 and 3. Remember, -1 and 3. Over here, 0, -2. 0, -2. So another way to look at this is when you're looking across the rows, the numbers should be the same. When you're looking down, columns should be the same. So when I do the math here, I end up with -5, -9, so that gives me -14. Here I got 0 and 3, so that's a 3. That's 0. That's going to be 6. So I end up with 6 there. That's 0 again, and that turns out to be, whoa, that would have been what, -2 again? Yep, so that would have just been -2. So, are those matrices the same? No. The only way that that actually happens is if you have what's called the identity matrix. So, be careful about that. You switch the order and you will get something completely different. So that brings us to this. the idea of a square matrix and an identity matrix. The identity matrix for any square matrix, easiest thing in the world to identify. It'll have one of the diagonals going down. Everything else will be zero. You'll have one in the center. And we do use this idea of the identity matrix when we're solving other equations. I think you guys probably would have played with it. I think we played with it in Algebra 1, where we had three equations with three unknowns, and we had to try and solve all three of these equations simultaneously. It was one big headache. However, if we use matrices to do it, it goes a lot faster. So, let's take a look at this. I want to find A times I. Now, this is the identity matrix. It's got a 1, and a 1. Now, when we say identity and we're multiplying, that means we're going to get exactly the same thing out that we put in. So, I'm going to write it out like I've done in the past. So, that means we're going to have 3 going across, so it's going to be 4 times. This thing is slowing up badly. 4 times plus 3 times plus -1 times. Problem is, how many of these do I got to actually write up? I got to write all. I got 3 of these that I got to put up, right? So it does come in handy here, especially me. Right, a heck of a lot smaller. So I'm going to write this out and see if you agree. This is where technology comes in rather handy. That's cheating, isn't it? But it reiterates this whole idea that if I'm taking this row, multiplying it by those columns, I always want to put those 3 in there. So, the next thing I got to do is 6, -2, and -3. So, if I want to put it 6 times plus -2 times plus -3 times. Okay? Can I just copy and paste that one again? Because it's just going to be that set. Little one there. Thing is, I'm going to give myself a little room to work with so that when I do the calculations, I got a place to go. And now I got the last set of 3. Plus 1 times plus 0. I got that set. So now I can just replicate that. Across. So now I've got to do the next bit. Well, the next bit is just simple. The rows, correct? Everything here is 1, 0, 0. So that means everything that I'm going to see now, this first one is going to be 1, 0, 0, 1, 0, 0, 1, 0, 0. So 1, 0, 0, 1, 0, 0, 1, 0, 0. That was it. That's why it mean that if you write this out first, especially when you get to larger matrices, it makes life a heck of a lot easier. So what's the next one's going to be? 0, 1, 0. So it means it's going to be 0, 1, 0, 0, 1, 0, 0. What's the last set going to be? Huh? Yeah. See the pattern, and that's all that it really boils down to for that. Now, if I remember this whole idea that anytime I multiply by a zero, I get what? Zero. So, if I look at this, I'm going to get 4. Do I care about those two? No. Here I'm going to get 6. Don't tell me about those. And here I get negative 5. Don't worry about that. That means I'm just going to get 3 here. This is going to be negative 2. That is going to be 1. Don't have to worry about the 0. So this is going to be negative 1 here. That's going to be negative 3. And that here is going to be 0. So if I put those numbers together for the matrix, which turns out to be 4, 6, negative 5, and 3, negative 2, 1, and the last one, negative 1, negative 3, and 0, is this the same as that? And the answer is yes. This is the identity matrix. The identity matrix, again, is I multiply it by this, I get back out what I put into it. And now, does this mean that you're going to have to be multiplying a whole bunch of garbage by the identity matrix? No. It's just going back and showing that, hey, if I've got the identity, I multiply it, that's what I get. There is also something called the inverse matrix. Kind of like the idea of a reciprocal. Because if you take a number, multiply it by its reciprocal, you end up back at that. So, it's one of the things that we're going to be working towards. So, moving on. What I'm going to do here is I'm going to give you a little time, let you determine whether or not this is true. So you got about 30 seconds. Okay, so if I want matrix A times B, okay, first thing I got to do is determine what the dimensions are. Right? So this one here is a 5 by 1, right? This is a 1 by 4. Can I multiply these together? The answer would be yes, because this one here, there we go, that matches with that. Can I multiply them the other way? So the only way that this works is A times B. I cannot take matrix B and multiply it by A. So, moving on. Give you a few moments. Sit there and determine whether or not this one will work. So, Kitty, this one work? If I flip it? But if I just want straight out A and it work? And the answer is no, because the 7 would have to match up with 4, and it doesn't. If I turn them around the other way and even took a look at B and A, would it work then? No, because B is going to be a 4 by 7. A is still a 4 by 7. So they wouldn't work at all. So this one is just a factor. So, so give you a few moments. Think about this one. So, Micah, this works. What are the dimensions of the output matrix? Well, it also supposed to give the dimensions of the product, what comes out of it. So, this worked, right? So remember, the output is 3 by 3. Okay? So that's kind of the nice thing. If those two match up, whatever these two numbers are going to be, just tells us what the rows and columns are. And that's usually more so just as a check to make sure that you wrote everything out correctly than it does anything for us. It's really just a check. So, what I'm going to do here is I'm going to give you 2 minutes, and I want you to work this one out. Multiply these two up. All right. Does anybody believe that they have the correct answer for the matrix? So, I'm going to start off here. First offhand, can I even do this? Rows by columns. So this is a 3 by 2. This is a 2 by 2. So, can I even multiply them together? The answer is yes. So now I need to go and have going across 4 times plus 2 times, correct? Now I only need 2 of those, so I'll need a copy and paste. Okay. So I've got my rows. 3 rows going across. 1 and 6. Last one, 3 and 9. Look good. Rows. Columns. Okay. First column, 0, 5. 0, 5. 0, 5. 0, 5. That's a row. Column up and down. So go across. Across. Okay. So now I got 3 and 8. So this is going to be 3, 8, 3, 8, 3. Okay. Do I have it set up right? Now it just 0, 10, 0, 30, 0, 45. All of this is going to be equal to 10, 30, 45. Over here, I've got 12, 16, so that gives me 28. Here I've got 3, 48, 51. And last but not least, I got 9, 72. So that gives me 81. Right here, right? I can usually do the hard stuff. It's when I get down to the adding and subtracting, multiplying and dividing that I mess up. Okay. Now, makes sense. See the pattern. So, do that. Write it out. This one's easier. I'll give you only 90 seconds on this. Write it out, and it is important. Write it out. You cannot do this stuff in your head. Even I won't do this. Remember, it's always rows by columns. All right. Always one step at a time. So, Davey, ask you if you I want to know what are the dimensions of matrix A? Rows by columns, 1 row by 3. So far, so good. Now, I was supposed to go. Yeah, already picked on you. So, Kaylee, what are the dimensions of B? 3 by 1. Multiply this thing together. Do we always have to check them? I would. Simply because if you don't, you start writing things out, and you're always going to run out of stuff, and you're going to try and make it up as you go. So, first thing, I've got one row, one column. My input is going to be 3s, output is going to be 1, so I'm only going to get one number out of this. So that means it's going to be 4 times parentheses plus negative 2 times plus 10 times. Okay. What goes in? Well, negative 1, 3, negative 6, stuff like that. Negative 4, negative 6, negative 60. So that looks like negative 70. I assume from the jovial behavior from back there, you got her. You got her. Excellent. So, so, I'm going to give you a couple of minutes. Have at this. Have at this. All right. First off, here, AB. Again, remember, rows, columns. So, there were numbers. Now, 1, 4, 1, 4, 0, 0, negative 2. So, that turns out to be 4, negative 8. So I end up with negative 4. Here, 2, 0, 2. Here, 0, 4, 0, 0, easy. Now I need to do BA. So BA, so I got to take the stuff from B, cancel. set it up like that, it makes life so much easier for fill in the blanks. So, 4, 0, I end up with 4. Now, would I actually have to go any further here to determine whether this is going to work? No, but I'm going to. So I get 16 and negative 4, so that's going to be 12. That's going to be negative 2 and 0, so I get negative 2. And here I end up with negative 8 and 0, so that's negative 8. Okay. So the answer to this question is all I can tell you is when we're multiplying matrices together, make sure that you write everything out. Otherwise, you were just going to be confused more so than you usually are. So, that's that.